Today we're going to talk about molecular structures and electron pair arrangements. Now these are both going off of your Lewis diagrams, so you should be familiar with how to draw those correctly. Anything to add, Mr. Giacomo?
No. You covered it for that first slide. Good job.
Thank you.
All right, electron pair or molecular structures. What are we talking about when we talk about those terms?
Here's the definitions.
Electron pair arrangement explains how bonding and non-bonding electrons are arranged around a central atom.
How bonding and non-bonding. I like that word and. It's both.
Yes. So when you drew your Lewis structures and your Lewis dot diagrams for molecules, you were supposed to show bonding and non-bonding electrons. So for water, for example, there is a bonding pair connecting oxygen to one hydrogen and a bonding pair connecting oxygen to the other hydrogen. And then you've got two non-bonding pairs sitting there on the oxygen.
Those are lone pairs, non-bonding.
Yeah.
Non-bonding. So why do we have to be concerned with that? Because the other definition only deals with the bonding electrons. Those are molecular structures. They both explain different shapes of the atom. The electron pairs consider bonding and non-bonding. The molecular structures only considers the bonding electrons for the shapes.
So 4 shapes that we're going to consider. Tetrahedral. There's that tetra word again, like that game Tetris.
Ooh, that means 4, I think.
Yeah, I think so.
Trigonal pyramidal means 3, trigonal, tri. Bent and linear. So what do these look like? Here is the tetrahedral structure. This is the most famous one. You're going to see it a lot. And we're going to consider methane for tetrahedral.
So really, you can see that the tetrahedral structure is making a tetrahedral shape. A tetrahedral shape is a 4-sided pyramid, and each side is a triangle.
Tetrahedral is the 3-dimensional representation of this Lewis structure. You can see the carbon and 4 hydrogens. It's flat. In reality, it's this pyramid-type shape.
This is the biggest challenge of what we're doing in this podcast, is we're going to use 2-dimensional drawings that we can do on a piece of paper to represent something that's actually 3D.
Yeah. And if we look at the central atom there, the carbon, keep track of how many electrons it has. It has 4 pairs. And notice they are all bonding. All 4 of them are connected. That's what gives us the tetrahedral shape.
So that means our molecular shape or our molecular geometry is tetrahedral for anything that has 4 pairs of electrons. And if they're 4 bonding, that's the molecular geometry.
So the geometry is only the bonding ones,
Yes.
right? Okay. Now, pay attention. The non-bonding ones, for the electron pair arrangement, you have non-bonding and bonding. Mr. Giacomo, how many non-bonding electrons are there in methane?
0.
0. Look up here. There are all 4 of them are connected. So in this case, it's the same thing. You can see the pictures here.
So methane, like we said, 0
Yeah.
non-bonding, but there's 4 bonding pairs.
It's tetrahedral. Electron pair arrangement is tetrahedral. The geometry is tetrahedral. But look at these other ones. These have lone pairs. Here in, this is ammonia, there are 3 bonds and 1 lone pair. How many total pairs is that? 4 tetrahedral. We didn't even time that. That was great. The water is next. Let's see if we can do it again. How many bonding pairs? 2. No, we didn't do it well. 2 and 2 non-bonding pairs. That one is tetrahedral.
Oh.
We'll never be in sync
We're
again. And then
Off forever.
HF, it has 1 bond and
3 non-bonding.
2, 3 non-bonding pairs. Tetrahedral, 4 total pairs. This is the
Tetrahedral,
total
way
number
off
of
there.
electrons. Notice you got a bunch of them are tetrahedral.
Just a hint, all of your electron pair arrangements are going to be tetrahedral in this unit.
We're always dealing with 4 pairs of electrons. It doesn't get that complicated. But keeping the definition straight can be complicated. Here's trigonal pyramidal.
So, trigonal pyramidal, for the most part, you're going to see 4 pairs of electrons, bonding and non-bonding. In this case, though, we have 4 total electron pairs and only 3 bonding pairs.
3 bonding. Since that number changed in the NH3, 3 of these are bonding, and then I have 1 lone pair. The bonding electrons affects the geometry.
So you can see in the picture there, in the middle of that picture, you still see that tetrahedral shape for the electron pair geometry, but the picture over to the right, the far right, that's the trigonal pyramidal molecular geometry. So we're taking out that non-bonding pair to look at what the picture looks like.
And since there's only 3 bonds, it's trigonal pyramidal.
So it's basically a pyramid with a triangle base.
Okay. 3 bonding pairs, trigonal pyramidal. Bent is our next shape. How many total electron pairs are there?
4.
So it's
I see a trend.
Yeah, so its electron pair arrangement is going to be what?
Tetrahedral.
Tetrahedral. See, here's the tetrahedral electron geometry. But what is the actual shape of the molecule?
Only 2 bonding pairs, and that makes the shape bent.
Bent. 2 is bent. Why? Because 2 parts of the tetrahedral are non-bonding now. So, but we only want to consider the bonds. So if we take those out, we get a bent shape for water.
Yep.
It's pretty straightforward.
That's pretty much it. That's that slide.
We're getting more and more cynical in these. The last one is linear.
Linear makes me think it's a line, because that's what that word means, right? Linear.
It does. Usually has 2 points. 2 elements make a line.
I'm on the ball today.
Notice total electron pairs, 4. That means the total, the electron pair arrangement, the EPA, is what?
Tetrahedral.
There's 4 sections.
Quite the trend.
But the bonding ones, it only has 1 bonding pair. Look at the HCl. It has, if we focus on the chlorine, it has 1 bond and 3 lone pairs. The 1 bond gives us a linear shape between the 2 molecules. So that's how we get linear.
All right.
So let's summarize what we have here. Summary. All the molecules we're going to be dealing with have 4 electron pairs.
If I could suggest something right here, if you're taking notes, this would be an ideal thing to put in your notes, because it's just summarizing everything you just saw.
Indeed. They all have 4 pairs. So the electron pair arrangement, which considers the total number of electrons, this is the one that looks at the total, these will all be tetrahedral.
We should probably cross out linear there. I don't know why
Cross
that's
that
there.
out.
Yeah.
That should be tetrahedral.
Yeah, it's just tetrahedral.
They should all be tetrahedral because they all have a total of 4. It doesn't matter what molecule shape we have, they're all tetrahedral. The bonding pairs, we're going to make another correction here on the fly. The bonding pairs, however, change the molecular geometry. The molecular shape or the molecular geometry only considers the bonding pairs. If you have 4 bonding pairs,
Tetrahedral.
I like it. 3,
Trigonal pyramidal.
then you get the pyramid. 2, bent, and 1 bonding pair is linear.
Linear, all right.
All right.
That's it for molecular geometry.
Great summary.